Evening, scholars. Larson here with a deep thought for you by Jack Handey. It goes like this. If you define cowardice as running away at the first sign of danger, screaming and tripping and begging for mercy, then yes, Mr. Brave Man, I guess I am a coward. Another deep thought by Jack Handey. Well, hopefully this won't scare you. This is our learning target for tonight. It's finding slopes of lines and describing rates of change with me as your guide. I just want to recall for you that we have been talking about linear functions, and we started out talking about a linear equation, and then we changed the notation just slightly and said it looks like this now. So here's our function notation, or a linear function. And what I want to remind you of is that the slope is how far something goes up and how far something goes across, or how far it goes down and across, or down and to the left. That is the rise over the run, and we do it just by subtracting the y values over the x values subtracted. And let's say that I was doing some work on my roof and I had an extension ladder. It is here. It is an awfully good-sized extension ladder. And I lean it up against the house, which is here. And I don't know how long the ladder is, but I do know that I have a 2-story, and it is about 20 feet tall. And when I measure with my measuring tape that is long enough to measure this, I find out this distance here is 5. So the foundation of the house is here, and the feet of the ladder are out here, 5 feet away. So what I can do is measure, and we always measure it in this order, how far up or down divided by across. That is always what we call slope. So here's an example for you. I'd like you to do it on your own. Use the equation m equals y2 minus y1 over x2 minus x1. Since this one was written first, x1, y1, x2, y2. Go ahead, pause, and tell me what the slope is. What I hope you found is that you found that the slope was equal to -2 minus a -5 all over 6 minus a -4. -2 minus 5 is -2 plus 5, or 3. 6 minus 4 is 6 plus 4 over 10. So I find out that the slope is 3/10. In other words, for every 3 I go up, I go 10 over. That is what we call the slope. Some key concepts for you to think about is if I have a positive slope, like in that last one, the last one was 3/10, not 3 over 3. But if I have 3/10, it's a positive number. And what I'd suggest to you is that if you go up 1, 2, 3, and over 10, looks something like this. That leans to the right, or the positive direction. Remember, this is positive, negative, positive, negative. If it has a negative slope, so for example, if it's -1/2, that means for every 1 I go up, I go across 2. 1 I go up, across 2. And that really doesn't have a slope of -1/2. I was just making it work. But what you will notice is it always leans the other direction. It leans towards the negative end of the x-axis. And if you have a 0 slope, it's flat. There is no rise. There is no run. It just goes across. And lastly, we've talked about it being undefined. That just means that it is straight up and down, and it's a vertical line. So I'd like you to do these problems on your own. Tell me whether they rise or fall. Is it positive or negative? And is it horizontal or vertical? I think you have one of each in here. Go ahead and pause and do that. You practice. Remember, rehearsal makes a person understand. So go ahead and do it on your own. Thanks. That first one, you should have found out that the slope is 0 over negative 10. No matter what order you subtract those in, you'll get 0 over negative 10. And anything, 0 over anything is just 0. So the slope is horizontal. In the second one, you'd end up with a negative 1/3, which means that it's leaning to the negative part of the x-axis and the line is falling. So it isn't vertical, it isn't horizontal, it's leaning to the left. And then the next one, you get a different slope here of 5/7, no matter how you subtract. And it's a positive number, and so it's leaning this way. If this is our axis, it's leaning to the right, or the positive end of the x-axis. And finally, the last one that I had you do, there's a 0 in the numerator or in the denominator, and you might know, and this might make sense as I describe it, but we can't take nothing and divide it into something because it doesn't go in there at all. It doesn't divide into -8. Nothing can't go into -8. So what we do is we come up with this idea of being undefined. It doesn't make sense to us. So that's a slope that says that the line is straight up and down. Must look like this, vertical. Okay, some vocabulary for you from your geometry years. Parallel lines, they never intersect. They're equidistant everywhere. Perpendicular lines, they form a right angle. I will tell you that, if I say this is shorthand notation for line L is parallel to line M. And we can also say that line A is perpendicular to line B. And I don't write out the words anymore. I just use that shorthand notation. The other thing that I'll remind you about is that if two lines have the same slope, they're parallel. So for example, if I have this equation and if I have this equation, even though the y-intercepts are far apart, the slopes are the same, and because the slopes are the same, those lines have to be parallel. The other thing that I'll remind you of is that perpendicular lines have negative reciprocal slopes. In other words, if that problem I had earlier, if the slope of one line was 3/10, and I found another line that had the slope of -10/3, if you flip something over, it's called the reciprocal, and then if you take the negative of it, these two are negative reciprocal slopes. And if these are slopes of the lines, they must intersect at right angles. Okay, a couple examples for you. I'll do one and then leave you to do the second one. Tell whether the lines are parallel, perpendicular, or neither. So I'm just going to say this is y2 x. No, I can't do that. Sorry, I'm backwards. I'm going to say this is x2 and y2. This is x1 and y1. And I'm just going to find the slope. So the slope is 1 minus a -5 all over -2 minus 0. 1 minus, 1 minus a -5 is 1 plus 5, or 6, all over -2. So the slope here is a -3 over 1, or just -3. That's this one. And then if I find the slope of these 2 points here, I'm going to take this as x2, y2, x1, y1. And I'll just say, okay, 10 minus 1 all over -3 minus 0. 10 minus 1 is 9. -3 minus 0 is -3. And I end up with the slope being -3. What does that tell you? The slopes are the same rise over the run, so those two lines have to be parallel. If I was to graph them, and if I knew what the y-intercept was, I don't, but I'm guessing they would look something like this. Okay, like you to take these two and find out the slope. Go ahead, pause, and use the equation y2 minus y1 over x2 minus x1. Didn't leave much space there for you to see that very clearly. There you go. Okay, pause. And we're back. What you would find when you found the slope of those two lines, one has a slope of -2, one has a slope of 2. Those aren't the same, so they are not parallel. They aren't negative reciprocal slopes. They're negatives of each other, but they're not reciprocals, so they're not perpendicular. They are just two lines that have reciprocal slopes. They're not parallel, not perpendicular. Okay, the last problem that I'm going to do has to do with really a real world problem, and we're going to talk about rate of change. In this case, we're going to have the rate of change of forest in New Hampshire over time. I've got this problem that we pulled out of a brochure. We see that in 1983, there was 87% of the land in New Hampshire that was forested. Only 18 years later, there was 81% of the land that was forested. You notice that it's going down. So what I'd like to do is use the idea of the slope as the rate of change. And in this case, we're going to say loss. Actually, we'd say forest percentage. Maybe forested land over the number of years. That'd be the rate of change. So let's start by making a table. And I see in 1983 that there was 87% of the land in New Hampshire that was forested. 18 years later, in 2001, there's 81.1%. So in order to find the slope, what I can think of is it's either a table like this or it's an ordered pair like this. And what we typically want to do is have the years on the bottom. And so I'm just going to take, because we always think of a rate of change, how much does it change over the year? And so I may have mixed up, I'm going to change something here really quick. Forget that table. Let's go back to this table and let's have the year here and forested land on the other side, because otherwise the fraction's going to confuse you. So 1983, 2001, 87%, 81.1%. That way it works out with your slope equation. So our slope is, we're going to take 87.0 minus 81.1. That's all over. I started with 87, so I'm going to go to 1983 minus 2001. So what I end up with is something like, it looks like that is a positive 5.9 on the top and a negative 18 on the bottom. And when I divide 5.9 by 18 negative, I get negative 327. And what that really means is that's a decimal value of how much is lost each, well, in the years from 83 to 2001. That's the rate of change per year. So that's a lot. So what we could do then is continue this table and say, okay, if it's 0.327 each year, what is the rate in 2002, in 3, in 4, and in 5? And we could just subtract each year that amount. And what we would end up finding is that by 2005, there's only just a little bit under 80% of the forest that remains in New Hampshire. So, thanks for listening. What our learning target has been is we've been trying to find slopes of lines and describing different rates of change between points, lines, and then in the case of the last example, forest land in New Hampshire. So thanks for listening, and you have a homework assignment to do that is 2.2 in your Tuesday folder, or 2.2 in your packet that is handed out.